My name's Sachin, and I work at Roboflow. Just a very exciting day for us. We just got our Series B today. So what better way to celebrate it than talk about what we do? So Roboflow is about a 5-year-old company. And what we're trying to do is we're trying to democratize computer vision AI, all right? And that means make it easy for developers who are non-PhDs or non-experts in machine vision to actually consume this form of AI, machine vision, in their applications, all right? And to that end, we've been creating this end-to-end machine vision solution. You can sign up for at app.roboflow.com, and you can do things like bring your own images, label them, train them, serve them, in an inference server, for example. And also, we enable users and customers to deploy these models at the edge so that you're not restricted to that round-trip time latency, which will not work for many of these vision applications. So that's a little bit about Roboflow. And today, I'm going to be talking about one thing, which is called Roboflow workflows, all right? Now, we all know a little bit about machine learning or machine vision. We all know you first train a model or you get access to an API, and then there's the part where you infer, right? You send it some data, it returns some responses, and then you got to do something with those responses. But the challenge of getting AI adopted in a larger scale is that pre-processing and post-processing, before you send your data to the inference server and it comes back, that's pretty complex at times. You got to do a lot of steps first to make sure the data is in the right format, for example. And then when it comes back, you probably want to run a set of business steps or logic to use that inference to come up with something which adds to your business value stream. So what Workflows does is, at the center of it, we have our Roboflow inference server. This is an Apache 2 licensed inference server, which will perform inferences on all kinds of models. But then we also latch on things like different pieces that are needed for that pre- and post-processing. So here's a list from our Workflows block gallery. So we've got a whole lot of stuff. So we can do things like cropping. We can add all sorts of models, whether they're trained in our platform or they are APIs, like we can use OpenAI. We can use any other model that is being hosted anywhere else. You can do Clip. As well as, you can basically take these blocks and attach them together in addition to that inference that's happening and come up with an AI application. So there's a whole bunch of these, and no, we're not going to go through all these. That's not the talk. So let's go and do some demos, right? Let's see if this thing works and why it's interesting. So let's start with the first example. So now this is a workflow. So we have this visual workflow editor. And it's the simplest thing you can do with machine vision. We have an input, which is an image. And we are going to run it through an object detection model. And in this case, this object detection model is actually a people detection model. So you pass an image. Oh, I'll make it a little bigger. OK, just a sec. So we're going to pass it through a model which detects people, and then we're going to do some visualization, right? So basic inference response, and then we kind of render that response. So let's see if this will work. So I'm going to select a file. So just before the talk, I took a picture of all of us sitting here, because we are people. And then we are going to see if this will work. So what's happening right now is that we define the workflow as that visual representation. And is taking that and the image that is being uploaded, and it's going to somewhere in the cloud, and it is trying to get the inference as well as the the other pre and post processing steps that we had in that particular workflow description in the UI. So just to look at it visually, so this was a picture we sent, and you can see down here it got a few people, right? Because models are like that. It didn't get a lot of people. So obviously, we chose a people detection model. It detected a few people. But we can do better, right? Because apparently, this doesn't capture a whole lot of people. So what are we going to do, right? We can either go and retrain the model or find a better one. But there are things you can do outside of machine vision which can give you a much better result. So the answer is not always to train a new model and go through that whole cycle again, right? So turns out that let's go and look at our second workflow, right? So here, again, it's a little small. I apologize for that. Let me see how I can make it bigger. All right, so here, it's very similar. But what we're going to do is we're going to use this technique called Sahi, which is basically like you take this big image that I passed to the inference server. I'm going to slice it into pieces. And then we're going to do the inference on those pieces, and we're going to stitch the result together, okay? And what's relevant from the workflow perspective is, now you could do all this in Python code, right? We are all Python developers or developers of some sort. But there's a problem in this world. There are very few of us. So how are we going to democratize machine learning and machine vision so that every non-engineer can build a workflow and run this sort of a complicated addition to the object detection to do slicing and stitching and getting me the results and visualizing that and making that a business application. So let's see if this will work. So we're going to do the same thing. We'll test the workflow. Go here. So I added the same image, and I send it the request. Now here, there's going to be a lot of inferences happening because there's not just one image. There are several images which are being inferred. But the point is to reduce the complexity of machine vision, of machine learning, so that it's not smart engineer people like us who do this, but everyone is empowered to do machine vision in their domain as they can achieve their goals there without being experts. So let's see what happens here with the Sahi edition. It's probably going to take a few more seconds. There you go. So a lot of inferences came back. Let's go see. So this was our original image. And as you can see, it's detected a lot more people because now it was able to slice those images and then do inferences on each of the individual images and stitch it back together, right? So simple technique. This is not a different machine vision model than what we used the first time, but we were smart about it. We sliced the images, we sent it, and we got our business result. So the answer is not always a better model. All right. So I've been talking about these models. You're wondering what sort of models am I using here? These are definitely not large models. These are YOLO-based models, which we take a base model like trained on Coco, and then we kind of fine-tune it based on maybe we had some images of people that were labeled, and then we got that people model, right? Very small model. I can download it to an edge device, and that's the power of that model, right? But maybe, we're in 2024, so there are VLMs. There is stuff like YOLO World, or there's Florence 2, things that can combine multimodalities of text and vision, right? So can I incorporate those into my workflows? So let's go to our third example. So in this third example, it's like more of what a researcher would do. So what I wanted to do is, I said, okay, I'll feed it model and image, and then I'll say, let's run Florence 2. It's a Microsoft VLM model. And there's also YOLO World, which is similar. And I wanted to compare both of them, all right? And the way I was going to compare both of them is very simple. I just said within the definition of this block that, all right, let's look in that picture for a table, chair, person, umbrella, spoon, and a cup, right? So I'm just going to ask both the models, here's an image, find me those things, all right? So that's the prompt, basically. So let's see what happens here. So for this example, I have another image because it has some of those common objects which I just mentioned. So I add that there, and you'll see in a moment what those objects are. So we, again, running it. So this was Florence 2 and the YOLO World. So this was the original image. So it's got all these objects here. And actually, if I go down here, so this is YOLO World. And that does not look like an umbrella to me. But I mean, to be honest, I haven't really tuned it or tried to play with the confidence and all that. But anyway, it detected something. And it's having trouble making out a cup from something else here. It thinks the pen is a spoon, and several other problems. I'm not here to bash up any model because I haven't played with it and probably haven't given it its due. But let's go to the other one, Florence 2. Microsoft released this very recently. And this thing seems to do a much better job. An umbrella is an umbrella, and this is not an umbrella. And then it thinks this, oh, actually, I have these labeled here. So there's a chair, there's a cup, there's a spoon. So it seems to be doing pretty OK. So, so again, the idea was not to compare these two models. The idea was to just show you how easy we are trying to make it to use these models and build your application visually like Lego blocks so that you can then take this, drop it into your application, and this whole thing is basically an API, right? So instead of giving you an inference server endpoint, we're saying we'll give you a workflow endpoint. And then you send your request there, and you get your response as your business case needs it, rather than just some JSON that then you have to parse later. So that was the third example. Now, the title of my talk said video, so I got to do video, right? And video is always fun. So what are we going to do in this video? So what we have in this video example is basically, don't worry, it says image, but it will be a video, I promise you. What we're going to do is we're going to take a video, and we're going to pass frames of that video through our inference engine. And we're going to use that same sort of similar model to what we use for people detection, but this is just the COCO weights. It uses YOLO V11, again, a small model. And we're going to try to find out, or to visualize, actually, in the video as it's processing it, when a person or a bird appears in the video in a region of interest. So this might have applications, say, in defense, right, where, say, you're trying to find out if a drone is flying in the sky there. Or maybe another application could be, say, you are an ad agency and you want to check that the TV network put your advertisement in that part of the screen during that telecast, right? So applications like that. And the demo is just coming up, but what I, again, wanted to say is this is all the definition that a business user needs to put into place to make that application run, right? And so let's try to run that. Now this, let me show you a little code because otherwise it's no fun. So simple thing, we are just We're going to run this inference. Actually, we're going to run it locally on my laptop, so it's not all that. It doesn't go to the cloud because we want to do real-time video, right? So we don't want that latency to the cloud and back. So what we're going to say is, all right, let's create this workflow pipeline. And there's a workspace that I've defined. There's a workspace, which is AI Tinkerers. That's your project within Roboflow. And then there's a video reference, which will be a file. It can also be an RTSP screen by the stream, or it could be a USB camera or anything else. And there's a workflow ID, which is basically the ID of that workflow, that visual graph that you just saw. So we're just going to run this, and we're going to run a video through it, right? So let's do it. And all right, so it's starting up. And we should see a video somewhere on. Oh, there it is. OK, so like I said, we'll try to detect people. We'll try to detect birds. And we'll try to detect for how long they've been in this square, which is kind of shaded on and overlaid on top of the video, OK? So let's see. So this is Elephant's Dream. Some of you who've done video research might remember it. So the video is running, and the inferences are being made. You'll just see as soon as a person comes. So, and you can see how long this person has been in the zone, right? And so this can be used to drive a business decision, like I got to pay my advertiser that much because he put my product here for 10 seconds, right? And so this keeps running. And the key here is, one, you can use any model. You can use any model that either you create in Roboflow or you upload to Roboflow from Hugging Face or anywhere else even. And you can also use some of these VLMs to drive the workflow. And as you can see here, these persons were not detected for a second. So you can always improve the model by bringing your own data and fine-tuning it even more. And so basically, you've got this whole tool chain, right from bringing your images in, labeling them, and getting your model into place, and then putting that in a workflow so that we can then build the business logic that you need to drive your business. So that's basically workflows. And you can see here the birds are kind of mechanical in this video, so they're not captured very well with this model, right? But so that's our job. So take this video, split it into frames, get into the labeling tool, label those as birds, and then we'll be able to detect them in that new model that you create. So that's a little bit of what Roboflow can do for you. And I think that's the end of the demos. I had only 4 of these. If you want to learn more about Roboflow, please visit our website. We also have a blog which talks about how to use vision and how to build applications like the ones we just discussed. And I think that's the end of my presentation. You want to take mine?
Okay, it's off. So running models on edge is always like a challenging problem. Like I want to know whether your system is doing any type of optimization when building the models, or is it just relying on having full enough edge data sets?
No. We do a lot of optimization. When you go to the edge, it's like you're sitting in a rail yard. There's a camera attached to a Jetson, right? A Jetson has a tiny, in relative terms at least, NVIDIA GPU out there. So what we do is when you train models, say on our platform, or even if you want to train them outside, you can specify sizes, right, for those. And there's always a trade-off between the size of the model and the accuracy or what have you. So we support, for example, training nano models, right, which will easily fit in there. You can download them in, and then you can run. We get like 40 or 50 FPS sometimes on a nano model learning, just running on a Jetson. So it's possible, and yeah, we spend a lot of time trying to improve that FPS.
All right, thank you.
Well, thanks for the talk. I know it kind of defeats the purpose of your business, but I'm gonna ask, like, is there any way of converting these workflows to code?
So everything's open source, so you can definitely look at how they're written, but that's a good point. I don't think we have a way of clicking a button and you get the Python code for it, but all the blocks that you saw are just open source, so you can certainly look at how it's written.
Right, I see. I understand it's possible to like reverse engineer the coding, but do you plan to add like the actual feature of serializing the code stuff to something, or like creating a Docker image from the workflow or something like that?
Right. So that's a great question. So the spec for this, so you know this we saw these workflows here. Oh, here. This is actually just JSON. The whole thing is defined in JSON. I'm trying to remember where, but there is a representation for this there where you can just see the raw JSON. And you can actually save that into GitHub, right? And then you can use that JSON to pass it to the inference server rather than downloading it from our platform.
Right. But I will still need like the whole inference server of yours.
So the workflow engine, yes, is built into the inference server. But again, it's open source, so you know, if someone's so motivated, they can certainly look at how it's built.
I just like I'm pretty satisfied with this design of how we build blocks and stuff. I just want to like I want to have an opportunity of using the result of it
Right.
outside the cloud.
Oh yeah. So
Not only outside the cloud, outside the inference server.
right. Oh, okay. So here, you know, I'm running it on a dedicated instance. It's a GPU machine running in the cloud because Florence 2 will not run otherwise. But you can actually go to localhost, right? And it'll run inference there. But at present, I don't think there is a way to run, say, a Triton inference server and workflows with it. So if that's your question.
Okay. Yeah. Thanks.
One more? Hi, so you mentioned that this is made for people other than engineers. Who are those people, and what is the most complicated thing that they've been able to accomplish without involving an engineer?
Well, there are many very complex use cases which have come up. And you know, now, of course, I mentioned it's without an engineer, but you certainly need to understand what an image is and what a model is. You know, you need some basic understanding. That's not going to go away. But what this does is, instead of making that one person on the team who's know-it-all for CV and you know, machine learning, it makes it a 50-people conversation, right? And so this can accelerate the adoption of machine vision because it makes it accessible to so many more people in the organization and in the community. But certainly, you do need to know at least a little bit to be productive. But we have a lot of examples and getting started. So
would it be correct to say that you might have an engineer put together the flow, but that flow is now more interpretable and editable by people other than that one engineer compared to Python?
Yeah, I mean, so there's always a mix of you know, technical expertise on teams, especially when you're talking to, say, non-tech enterprises or companies. There's no way there's going to be someone who understands machine vision there, and they cannot afford to hire one person just for this. So, you know, it's a mix of several things. We also help to support our customers with help when they need it, and we try to we try to make them successful with the least amount of friction, and try to get the fear out of people about, oh, it's AI or it's machine vision and I need a PhD.